University of Maine system encompasses 7 public universities in the state. It runs a number of research projects involving high-performance computing aimed at driving advances in areas such as climate change, ocean and atmospheric sciences, chemistry, engineering, forestry, bioinformatics, and medicine. The University of Maine system wanted to find a more scalable, sustainable, and easy-to-manage approach to storage so that it could grow capacity in line with budgets and demand, while reducing administration time and effort. The university determined that Ceph FS, an open-source software-defined storage solution, would offer it best performance and value for its requirements. However, it was clear that setting up and managing the software would require considerable knowledge and new skills. To minimize the overhead on its small storage team, the university looked for a prepackaged vendor-supported implementation. The University of Maine system opted to deploy SUSE Enterprise Storage, an intelligent software-defined storage solution powered by Ceph technology and backed by built-in management tools and comprehensive support.
Our experience with SUSE has been exceptionally good. The SUSE team helped us define the configuration we needed to meet present and future demands and stood by us through our extended testing periods. SUSE Enterprise Storage has already brought clear improvements to our deep learning projects. For example, one of them requires 2 million files in a single directory. Putting these files into SUSE Enterprise Storage has actually increased performance more than 10 times compared with our previous storage solution. I really wanted to keep storage administration as simple as possible with full expert support if something goes wrong. I also wanted it to be simple to hand over so that another team member can handle administration without having to understand my homegrown scripts. The SUSE team was really good to work with. They helped us define the configuration we needed to meet present and future demands and stood by us through our extended testing periods. One of the other things I really like about working with SUSE is that we've been trying to do something a little different with our storage system by spanning it from the Orono campus to the Portland campus, which is about 100 miles away.
With SUSE Enterprise Storage providing resilient, high-performance storage of data on common off-the-shelf hardware, the University of Maine system has a solution that matches its research ambitions without incurring unsustainable costs.
What we really appreciate is that this keeps our internal team free to focus on driving new value for the university and its life-changing research projects. Thanks to the stability and ease of management of the SUSE solution, we have significantly reduced the time we spend managing live and archived data.
So that's me. I'm Steve Cousins. I'm from the University of Maine system. We were Forest Flag as a cloud administrator as well. I'm the HPC administrator. I grew up in, born and grown up in Maine, lived in Orono most of my around Orono for most of my life. Studied at the university, both undergraduate and graduate. Working with computers off and on for 28 years, mostly on for the last 21 years at the University of Maine system. And the past 12 years focused primarily on HPC. I gave this talk in Dallas, and some people didn't know where Maine was, so we're, I'm sure you all know. Famous for a few things, lobster, especially Stephen King was right near us.
And infamous for what?
Excuse me?
Infamous for what?
Mosquitoes.
I know nothing about me.
Texas to try.
Excuse me?
So come to Texas and check out our mosquitoes.
Do you have mosquitoes in Texas?
Oh yeah.
Turn this on. My wife sent this to me this morning. We were supposed to get rain, so this is what rain looks like in Maine. So the University of Maine system is, as the video said, was made up of 7 campuses, but we also have a number of outreach centers as well. The campuses are in the purple here. Actually, we do, I guess it's the blue. It's a big relatively big state, from Fort Kent to Portland. I don't know, it's like 300 and some miles, 350. So we're spread out geographically quite a bit. Well, I won't go into the networking, that's a different talk, but that's been a challenge. But I'm at the Orono campus, which is it's called the University of Maine. That's what they call the flagship campus. It's where the bulk of the research, it's the PhD granting campus, and it's where most of the research gets done. But there is research at other universities throughout the system as well. So we try to fit the needs for that. I thought there was another slide there, but as far as HPC, why is that there? I'll go here first. So HPC at the University of Maine started roughly around the year 2000. Got a research grant from the Army to build at the time, a Beowulf cluster. It was literally desktop nodes, 206 of them connected, but at the time that was enough to get it in the top 500. 2004, we got another Army grant, used Xserve, Apple Xserve systems. It was a prototype for a cluster at the Alabama, Army Alabama, was it Huntsville? I can't remember which one it was. I wasn't really involved with the HPC administration at the time, but I was a user. I was in the School of Marine Sciences, and we were using the system when the Army was not. In 2012, a couple things happened. We were getting a new cluster at the time, and the system decided that they wanted to focus on research computing, and so they took us, who previously had been just the Orono campus. They took us over, called us the Advanced Computing Group, and then we started in the newly renovated data center in Orono with that. Since then, we've added Forrest and a number of other people to do cloud computing. We do backup for departments and data management planning for grant proposals to help fund data storage requirements for the grants to be able to use our system. And then archiving, we have for the data management planning, we offer archiving of the data free of cost after the grants are finished. And then we have a data specialist who does data management and presentation for creating web portals to customize portals for given data domains. Actually, I'll go back here. The HPC system that we currently have, the progression has been, we kind of started out in 2012 with that new cluster. It was a 512 core cluster. As years go by, we've been able to upgrade or add to it, and then finally upgrade to newer Haswell, at the time Haswell, Broadwell, and now Skylake systems. We have a few GPU nodes, some visualization systems. Our storage systems right now are just a Lustre scratch space system and a number of ZFS systems. We have 3 ZFS systems in Orono and 3 at the data center in Portland, which is about 100 miles away, for backup. This is the Advanced Computing Group. There are 6 of us now. We do have also one person as a cyber infrastructure engineer that was a NSF-funded position, so he helps everywhere. So our primary storage, what we have live right now for all home directories are these ZFS systems. We generally have a bunch of super micro systems where there's a server with 36 drives and then a JBOD attached to it with 45 drives to make an 81 drive system. And then as we need more capacity, the practice has been we just get another one of or another two, one for Orono and one for Portland, and kind of do manual replication. It's automated, but it's scripts that I created rather than a package. And we do have some grant proposals out for research that are in bioinformatics and ocean modeling that are projecting to need a lot more storage. And just thinking about doing this multiple more times and adding the complexity of managing them all, I started thinking about other ways to do that. Started thinking about Ceph. We've been using Ceph in the cloud side for quite a while. We have an OpenStack system that uses Ceph as the back end. And I'd been aware of CephFS, but it hadn't been actually used much for real data until in 2017 I found that SUSE was starting to use it in their enterprise storage system. So I contacted, I guess, Paul Augustiniak, and eventually got a hold of Alejandro, and we've been working together ever since. So we wanted the primary reason, we wanted the performance to be there, and early on I'm also a campus champion on the NFS Exceed program, and there's a list there, and I asked if anybody has been using CephFS at all, and one person from the Oklahoma Federal Reserve Bank said that he was, and we talked quite a bit, and he's been using it for real for even before it was ready for prime time, and he got me thinking that we could actually do this, and he's able to get, his primary goal is for performance. I do want the performance, but I also want the scalability, ease of management, that sort of thing. And for education institution, affordability was a big factor as well. Yeah, so once SUSE Enterprise Storage started including CephFS, we started a test project to implement it, and that was 2017, and we're only now starting to actually roll it out, but we're actually still doing a little bit of testing, but we will be scaling it up in the near term. As I say, it's been a long process. We're a small group. Other things have taken priority at different times. Now storage is really, we are running out. Some of those projects are coming online and basically using up our existing storage. So rather than trying to set up another ZFS system temporarily, I'm focusing on bringing the Ceph system online. So the process was that we decided that we wanted to do it. I wasn't sure whether we wanted to do it ourselves or with a package. Finally decided with SUSE to save time and make it more manageable. If I go on vacation, somebody else be able to take it over as well. We've tested a number of different configurations, and that's taken a while. mostly because of me. SUSE has been very good to work with. Alejandro's been great. Anytime I ask, can we try something, he'll hop on and help me set it up, but mostly do it himself, but shows me what he's been doing. And the big thing really has been willing to try different things. With the biggest thing has been wrestling with 2 data centers. Do we keep it all in Orono and then replicate down to Portland, or do we try to, I've had it in my head, we might be able to span it and have one system that goes both ways. And it's an ongoing process that goes around and around, but for the most part, it's working now, but there are obviously some performance issues. But anyway, I have this feeling that doing it with other vendors, I have worked with other vendors with not this type of thing, but other things, and they've been more kind of siloed. No, this is the way we do it. With SUSE, it's been great. They've been willing to try different things and actually help to or see about putting features in newer versions that so if we can't have it now, might be able to have it later on. So the design right now with the test was that we have, single master node, fairly standard, 3 monitor nodes. We do have separate nodes. I had enough old machines to put these on, 2 metadata nodes, and then 4 OSD nodes with some older storage systems. And back and forth quite a bit with David Byte and Alejandro, and we settled on 7 SSDs for this type of system with 42 drives, and then 2 for the journals, and then 2 SSDs for metadata pool. So each node has a couple disks that can go into that pool. And we do, all of our HPC high-speed network is InfiniBand in Orono. We don't have any InfiniBand in Portland. It's all gigabit of some sort, Ethernet of some sort. And so we, in Orono, I put in a bridge basically to span InfiniBand over to Ethernet, and then we can send 10 gig Ethernet down to Portland, and it's all on the same VLAN.
6 nodes now, right?
Yeah, we do have. So we got some funding to add some more nodes. We've got two new nodes in place. We've added one of them in. I'm in the process of adding the second one, and then we're going to be phasing out the test nodes because they're for a few reasons. Might bring them back in at some point, but for now we'll just replace them and then go forward. I mean, part of the idea also was to try to reuse some of the hardware that we have. As we phase ZFS systems out, I'll probably be repurposing some of those. They're still within the scope of performance and memory capacity and networking to be able to, and redundancy to be able to bring into this system. So we'll have 6 nodes in the very near future. We've got funding for another 3 OSD nodes within the next month or so, and then I'll be able to, as we move the ZFS systems, the data over to CephFS, that'll free up some of the ZFS systems, and I'll be able to bring in a bunch of those. So I think within 6 months we'll probably be up to about 14 OSD nodes, and whether that's all in one cluster or if it's primary in Orono and a backup in Portland, it'll be some iteration of that. Yeah.
Is this separate from the Ceph cluster you're using for OpenStack?
It is right now, yeah. The OpenStack cluster that we had in place had Ceph initially. That's 3 years? 3.5 years.
Do you plan on just bringing it all together in one larger?
Yep, we're going to be, he's working on bringing the newer generation of OpenStack system. We're receiving hardware for that, and that'll be in place sometime this summer. And the idea is to use the Ceph system, the new Ceph system for that, and then basically turn off the old equipment. So, yeah, primary use for the data in Portland is just disaster. You know, we want to be able to tell everybody we do have and actually follow through, have off-site backup of everything. People like that, and I sleep better at night knowing it's there. We do have, we're closely tied, since we're part of the system, you know, right down the cubicle center that I'm in is the networking group. We work closely with them. They've set up a dedicated set of fiber for us to get down to Portland outside of the scope of the router. So we've been able to get the latency down pretty much as low as we possibly can, and it's just under 4 milliseconds. And so currently we are two OSD nodes in Orono, 2 in Portland. We've got 2 more that we're putting in Orono right now, and then the next 2 will go back down to Portland. And we're ongoing with testing and benchmarking. So this is the motivation that I just talked about. I mean, one of the reasons also for doing it as one cluster initially was I thought, well, rather than having to set up 2 sets of monitor nodes, 2 sets of master and metadata servers down in Portland and incurring the licensing costs associated with that, we'd, by having one cluster, if it would work, would save us some money on an annual basis. And since we're a small group and funding is an issue, that was appealing. But, you know, we're still weighing the pros and cons. And in the scope of things, as we scale up, that might not be as much of an issue. But yeah, since disaster recovery performance really isn't the big issue, so we could probably combine OSDs and some of the other services to save on those licensing costs. So the alternative is, I mean, the opposite side of that is that by imposing that 4 millisecond latency, it just might be dragging everything else down. I mean, I still have it in the back of my mind that there might be a way to make it work, but it might not be worth exploring after a point. The caveat to that is we do have another project that we're working on. We've put in a pre-proposal for something called the Eastern Regional Network. That is it was a prototype for a system that we're hoping to be able to be asked to put a full proposal in for the NSF. It's a collaboration between a number of institutions in the Northeast, starting down from New Jersey on up, New Jersey and Pennsylvania, New Hampshire, Massachusetts, Maine, and a couple sites in Maine, and some others, I think. Rhode Island might be in there. And it's a set of clusters at each of the sites, including storage. Well, right now, for the proof of concept, all the storage is in New Jersey, and it's a problem. Basically the idea is each site has an HPC cluster that is shared with all the others, and you can log into your local HPC site and then submit jobs that can go to other sites. So if Pennsylvania or some other site has large memory nodes, GPU nodes, or something that your site does not have, you can take advantage of that. You can run your code without much overhead. All the IDs are federated through the Slurm Federation, and the proof of concept worked as far as making it, so you can submit jobs, but only certain types of jobs are really workable because of the storage bottleneck. So going forward, if we're asked to do a proposal for it, it's a $20 million grant, and part of that will be trying to figure out how best to deal with the storage. And everybody is saying they want some storage on their local site. If there was a way to combine them to be one large Ceph system, then then it wouldn't matter. You wouldn't have to copy data. I log into my HPC system at my site, and I see all the data that you would see in Pennsylvania or elsewhere. And I could submit a job in Pennsylvania. It would run from my home directory, and it theoretically would all work. That latency issue needs to be resolved. But this is another kind of thing that's in the back of my mind. They're wrestling with how to deal with this, and I'm exploring this for both our own purposes and for this. I have a rough idea what the outcome will be, but I still want to explore it. So some of the results that we have had just with the test cluster, and this is with old hardware and not tuned super well, and with me primarily causing problems periodically so that the system isn't available. The user who is using it does know that it's in testing, but he's basically got 2 million image files in a single directory. The software that he uses requires them to all be in a single directory. And the first step of his process is to scan through the file information for each one of those files. And over NFS, that takes about 10 hours just to do that part. So that's not good. With CephFS on the video, I said it was a 10-to-1. That's what he initially told me. It was about 10 times faster. Lately, I've asked him, it's probably due to caching, but he runs it, and it's pretty much instantaneous, that part of it. Second step of the process that he runs, this is all on GPUs. They process each file and do image recognition, and NFS over ZFS, each file that, part of the reason for scanning is it figures out, I'm not sure what it does to figure it out, but it figures out which files are good candidates to do what he needs. And then once he gets a set of once the program gets a set of files, it goes through each of those, and it takes about 3 seconds per file to process. Unfortunately, on the CephFS system right now, that's about 6 seconds per file. So old hardware, Alejandro thinks there's some tuning we can still do to improve that, and obviously I think the latency is probably affecting that quite a bit as well.
So the NFS was a single site, and the
Yeah.
CephFS was a multi-site.
That's right. Yeah, so NFS, that's all in the same data center as the GPUs. high-speed InfiniBand, sub-microsecond, sub-microsecond latency versus 4 millisecond latency for that. It's just a single file, so the latency might not be a huge deal, but something is getting in the way, and we think we can probably solve that. But since he's got so many files, just that little difference more than makes up for the 10 hours. It's still faster to run it on ZFS right now. But I think I'm pretty positive we can overcome that. As far as the resiliency goes, that's been it's been really nice. Like I said, I have caused some problems. One time when I was moving a storage system down to Portland, he started up a job, and I had crossed a wire in Portland, and so one of the storage systems didn't get access to the drives that it thought it was going to get, and so it didn't even come up. The OSD processes didn't come up, so that was offline, and he was running it, and I was trying to figure out what the problem was, and I finally got the engineer down in Portland to plug it back in, started rebalancing everything, and it came back up. Everything was fine. And then we have had network disconnections, fibers being cut or something periodically. Basically, the job just stops, and it comes back when everything's up again. And the Ceph system has been, it wasn't able to do any writes at either site, obviously. So it just picked up where it left off, and I was amazed. I was worried that something bad was going to happen. Still testing some different replications and erasure coding, different pools. I haven't tested the erasure coding pool with the GPU case that I was talking about before, but hope to do that soon. We're going to decide whether we can, which method we're going to go with, one pool or one cluster, or set up a backup cluster. And also, this is kind of old. I was wondering about cache tiering, as whether that could be put in place to offset the latency issue. But the more I hear about it, the more that sounds like that might not be an issue. If anybody has other ideas about that, I'd love to hear it. So this soon to add more nodes. The new nodes that we've got, they're basically the same nodes that we had from the other system, just without a JBOD attached to it. So 36 drives, 30 of those are for data drives, using 10 terabyte drives, 5 SSDs for journals, and again, 2 metadata SSDs. And we do have some new metadata servers as well, or a metadata server. And then, like you were saying, we'll use that as the backing store for the next OpenStack system.
Is that Blue Store?
Yes. Yeah. Yeah, this is version 5 of SES, and we started with Blue Storm.
5 or 5.5?
Now it's 5.5, but started with 5.
And like I said, once it's in place, we'll try to migrate ZFS systems, and just by adding some SSDs and replacing the drives, since some of those systems are 5 to 6 years old, so their drives are dropping faster than I would like at this point. But so for capacity and for that, we'll add newer 10 terabyte drives probably, and we'll have 14 of them in place within the next 6 months, I believe. So this is our old system, basically the new system's very similar hardware. So again, with SUSE, you know, I know what I'm doing is probably a little crazy. They've stuck with me and don't make me feel like it's stupid to try it. Keep on trying to chip away at different things that might help and give it another try. So it's been great. Oh yeah, I was at a session yesterday that I thought was very helpful. So I just want to recommend this for anybody starting up new clusters. This had a lot of good information, so I'd recommend it. And thank you very much for Alejandro and Paul Gosteniak was a great help. I ran into him recently. I guess he's now at IBM, but I still wanted to thank him. So, and if anybody has any questions, please let me know.
If I can ask,
Yeah.
so which are some of the things that you wish to see from us
Oh, yeah.
going forward?
Well, one of the things with the ZFS system, we use all SAS drives, and we do have multiple HBAs and backplanes to allow for you know, HBA to drop out, and we use Multipath to you know, so if that happens, which it has happened, the system's stayed up and running. With a new system that we just new OSD node had multipaths set up, but the SUSE, the deep C scripts didn't know how to handle that, so I had to actually go in and disconnect cables inside the machine from backplanes to.
So multipath support for deep C. All right.
Yeah, that would
Okay.
be big help.
Okay.
Yeah.
Anything else, or?
I know there was something else. I'm
Okay.
drawing a blank. Can
Right.
you remind me what?
No.
I know we've talked about other things. That was the latest thing. And
Yeah.
I know there are people in the room that probably have information about that. Is anybody know about Multipath? Is that on the roadmap now, or?
Yeah, that's something that we can talk about.
Yeah.
Yes, but I mean, it's good that you have a really short list.
Yeah, yeah.
So,
There is, yeah, like I say, there is something else I can't think of right now.
yeah, thank you.
Yeah.